This is lesson 2, 7th grade, and it's on properties of operations and then also sequences. Okay, so the first thing I want to talk about is inverse operations, and you'll want to write this down, okay? Inverse operations. I think the first time you would have learned about inverse operations would have been when you were doing fact families. Do you remember what fact families are?
Kind of.
For example, 2 plus 3 is 5, 3 plus 2 is 5, and then the inverse operation of that would be
5 minus 3 is 2.
5 minus 3 is 2, excellent, and
5 minus 2 is 3.
5 minus 2 is 3, okay? Those are inverse operation because if I did 2 plus 3 equals 5, the way to change that and make it different is to do 5 minus 3 equals 2. And so that one's called an inverse operation. Okay? So, as you can see, that's one. Okay, so the first time you would have realized this is with fact families. Okay? Now, let's talk about the first property that we're going to look at is commutative. Okay? Commutative property. And because we're working with addition right now, we're going to do the commutative property of addition. Okay, so let me show you what the commutative property means. For example, 2 plus 3 equals 5. Okay, and then also 3 plus 2 equals 5. So basically what the commutative property means is that no matter how I change out the addend, remember these are called addends, no matter how I change those out, I'm still going to get the same sum, the same answer, okay? So if I did 5 plus 3, it would equal 8, and then if I did 3 plus 5, it would equal 8. So no matter what, you're still going to get the same answer no matter how many times you turn it. Now, a way you might see it is A plus B equals the same thing that B plus A equals. Okay, that was if we were using letters in our problem. Okay, A plus B would equal the same thing as B plus A. So, for example, if A was 5, we'll make all my A's 5, and if my B's were 3's, then does that equal the same thing? Yes, 5 plus 3 is going to equal 8, 3 plus 5 is going to equal 8. So the answer would always equal the same. Okay, and the way I remember this property is, do you see these two M's right here? Okay, they kind of look mirrored, okay, and so does A plus B equals B plus A. It looks like a mirror. If I were to put a mirror right here, it says the same thing on one side that it does on the other in opposite directions, okay? So these two M's, that shows me that's the commutative property. But what does it mean?
Always the same.
The answer is always going to be the same no matter how I change up my addends. Okay, excellent. All right, now let's ask ourselves, is there a commutative property of subtraction? Okay, and there is not. And here's why I'm going to tell you why. Let's say I did 5 minus 3, that's going to equal 2, right? Okay, but let's say I changed my numbers around, and instead of saying 5 minus 3, I said 3 minus 5. Is 3 take away 5 going to get equal 2? No, it's going to be negative 2, okay? You'll learn about negative numbers later, okay? But if I had 3 pencils and I took away 5, then I would obviously take away 3 of them plus 2 more, and so I would have a negative 2. And so the commutative property does not work with subtraction, okay? Because it does matter how you change them out, all right? Now, the next one we're going to talk about is called the identity property. Identity property of, and we're working with addition again. Okay, the identity property of addition. All right, for example, let's use letters. A plus what would cause us to still equal A? So if let's say I said A was 8. 8 plus what is going to equal 8, because my A's are going to stay as numbers, okay? What would always go here for 8 to keep its same identity?
0.
0, okay? So whenever I'm working with the identity property, okay, in order for something to keep its identity, 8 is my number that I want to keep, 8 plus what equals 8 still, okay? So because we want to keep the identity of 8, we have to add a 0 to it. If I added a 1 to it, that would change its identity to a 9. And 8 would no longer be an 8, it would be a 9. So 1 does not ever work when you're working with the identity property, okay, of addition. Now, let's talk about inverse operations again. And we're working with inverse operations and we were doing adding and subtracting. But now we're going to work with inverse operations with multiplying and dividing. So for example, 4 times 5 equals 20. So we kind of be making a fact family. Okay, what else equals 20? 5 times 4, right? Okay, but the inverse operation of multiplying is what, Isaac? What do you think the inverse, the opposite way we would do an inverse operation of 4 times 5 equals 20?
Divided.
Divided. So how would I make this one look?
4 divided by, no, 5 divided by, 20 divided by 5.
20. And I'm going to do divided by 5 would equal 4. And what's another way?
20 divided by 4.
20 divided by 4 equals 5. Okay? So these are inverse operations of the two. All right? Now, let's talk about this word, commutative property. And this time we're going to do the commutative property of multiplication because now we're looking at multiplication. Okay? And I'm just going to put multiple. Okay, multiplication. All right, because we were working with the commutative property, do you remember what the two M's kind of show?
Mirroring.
It kind of mirrors. Okay, so a while ago we were saying that 4 plus 5 is going to equal the same thing as 5 plus 4. Okay, do you think this is going to work for multiplication? 4 times 5 equals the same thing as 5 times 4. Is that true?
Mm-hmm.
Yes. So the commutative property also works for multiplication. Now, will it work for division? What do you think, Isaac?
Yes.
Let's try it and see. Okay. Here's the commutative property of division. Okay. Will 20 divided by 4, okay, I'm writing it a little different, be the same thing as 4 divided by 20? 20 divided by 4 would be 5.
Yeah, it won't work.
That won't work. 4 cannot be divided by 20 and get the same answer. You would not get 5 here. Okay? So the commutative property does not work for division. Okay? Now, back to the identity property. And all we're doing is just going, we were doing all adding properties, and now we're doing the properties of multiplication. So now we're going to do the identity property of multiplication, of mult. Okay? The identity property of multiplication, okay, for example, I have a 5 and I'm multiplying it. What do I keep? What do I put here for 5 to keep its same identity?
1.
A 1 this time. So in order for the 5 to keep its same identity, we have to have a 1 here. Okay? If I had any other number, let's say a 2, would I keep 5?
No.
No, that would make it 10. What if I did a 0?
It'll keep it at 0.
That would make it a 0. So 0 will not work. So the identity property of multiplication, that is that. All right. Now let's talk about the property of 0. The property of 0 for multiplication. We kind of just did this one. Okay? Property of 0 for multiplication. So this would be, for example, 5 times what would equal 0, because we're wanting the property of 0. So I'm not worried about keeping my identity anymore because I'm working with the property of 0. So for 0 to equal, for this to equal 0, what's going to have to go here?
0.
A 0. Excellent. So no matter what number I have here, if I multiply it by 0, I will always get 0. And that's what the property of 0 states. Okay? Now, there are operations in math that are called binary. Okay? It's kind of like bicycle. That means there's 2. Binary means that we work with 2 numbers. Okay? So, for example, if we wish to add 2 plus 3, okay, we're working with 2 numbers. Okay? But sometimes you're going to end up seeing 2 plus 3 plus 4. All right? And a lot of times when they do that, they will group two of these numbers together, a binary form, and work those first and then add the 4. So if, for example, this one would be 2 plus 3 is 5. And then we bring down the plus 4, 5 plus 4, which equals 9. Okay? So that would be how you would do that. Now, you can also group this a different way. All right? So, could I group 3 and 4 together and get the same answer? Let's try. So this time we're going to group these two numbers together. 4 plus 3 is 7, and 7 plus 2 is 9. Did we get the same answer? Yeah, we did. Okay. What this is called the associative property. Associative. Okay? Do you remember me telling you about this?
Yes.
Yes. So for example, let's make our numbers people. Okay? Let's say this one is Toby. 2 is Toby. Plus 3 is Eli. Plus 4 is Isaac. Okay? Now, today, Eli and Isaac are going to associate with each other. And they're leaving Toby out until the end. Okay? But earlier, we used the associative property like this. And Toby and Eli associated with each other, and they left Isaac out until later. Okay? So that's how it helps me remember what the associative, they choose to associate with one versus the other. Okay? So that's the associative property. All right? It works the same with multiplication. So, for example, if I had 4 times 3 times 2, I could group 4 and 3 together. And 4 times 3 is 12, and then 12 times 2 is 24. Or, I could group the 3 and 2 together, which would get 6. 3 times 2 is 6, and then 6 times 4 is 24. So either way, we're going to get 24 as our answer. All right? And that is the associative property of multiplication. Okay. Now, let's ask ourselves this. Will the associative property work with subtraction or division? Okay. So, for example, 4 minus 3 minus 2. Okay. 4 minus 3 minus 2. All right. And then 4 minus 3 minus 2. Okay, let me make sure I wrote that down right. Okay, so let's see if these equal each other. Okay, so this one, 4 minus 3, I grouped together. Now I'm going to group the 3 minus 2 on this one. All right, so let's look at these two together. Isaac, 4 minus 3 is what?
1.
1 minus 2.
Negative 1.
Negative 1. All right, now we're going to work with our parentheses first. 3 minus 2 is
1.
1, and then 4 minus 1 is
3.
Do we get the same answer?
No.
No. So, does the associative property work with subtraction?
No.
No, it does not. Okay? Now let's try division. All right? 8, now I'm going to write it like this. 8 divided by 4 like that, divided by 2. Does that equal the same thing as 8 divided by 4 divided by 2 a different way? So this time I'm going to group these two together, and the next time I'm going to group these two together. Okay, so I'm using the same numbers, but I'm grouping this ones together, and then I'm grouping these two at the end together. Okay, what's 8 divided by 4, Isaac?
2.
2. What's 2 divided by 2?
1.
1. Okay, let's try this one. What is 4 divided by 2? We do the group first.
2.
2. 8 divided by 2?
4.
4. Do they equal each other?
No.
No. So the associative property does not work with division either. All right? You feel like you understand it?
Yep.
All right. Now, sequences. This is our last bit. Sequences. What is a sequence? Well, there's an easy sequence. 0, 1, 2, 3, 4, 5. This means I'm just adding plus 1, plus 1, plus 1, plus 1, plus 1 each time. Okay? Another sequence would be like 2, 4, 6, 8. And what am I doing here?
Counting by twos.
Yeah, so I'm doing plus 2, plus 2, plus 2. Okay? This one's a little bit harder, and I want you to see if you can figure out what it is. Ooh, it's kind of difficult. No one figured this out last year. This one's a multiplication sequence, but it's not in between this and this and this.
You're adding by the odds. 3, 5, 7.
Okay, that is one way you could do it. Smart, Isaac, very smart. So what he did is went plus 3, and then the odd number after 3 is 5. So he did plus 5. The odd number after that is 7, and you would get 16. Excellent job, okay? That's one way you could have figured out what the sequence is. So what would be the next one? Plus
9.
Okay, and then 16 plus 9
is 25.
25. Okay, another way you could have done this is, this one is 1 times 1, answer. 2 times 2, answer. 3 times 3, answer. 4 times 4, answer, and so forth. And so the next one would be 5 times 5, answer. Okay, so those are all different sequences of how you would do that. Okay, and y'all did, that was perfect, Isaac. Great job. Okay, but these numbers are all numbers that are used in a perfect square. Okay, like I said, 1 times 1 equaled 1, 2 times 2 equaled 4, 3 times 3 equals 9. So for example, let's draw out a perfect square. Okay, so it's going to be 1, 2, 3, and then I'm going to go 1, 2, 3. Okay, so if I have 3 and 3, what am I going to get? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I would have a perfect square. Got it? All right. Now, this is probably going to be the hardest thing you understand, but if you really pay attention, you'll get it. Okay, this is probably harder a little bit. Let's say I'm going to have a chart. Okay, you probably need to write this chart down. Okay, and I'm going to call this position N. Okay, and the one underneath that one I'm going to call term K. Term K in position N. Now that sounds kind of weird, but all that means is this N and K are going to be, remember how we talked about letters in a math problem? Okay, they're going to actually show us something in a minute. I'm going to use the number 1, 2, 3, and 4. Okay, and so I'm going to separate them because they're all going to be used differently. Okay, so once you write this chart down, we'll actually perform the problem. The problem looks like this. K equals N times N. And now remember that dot means times. It's not down here as a decimal. Okay? K equals N times N. Alright? And so we're going to use our N's. These are all our N's. So we're going to use our first N. Our first N is a 1. So if I were to put a 1 here, and this N I'm going to put a 1, what would my K equal?
1.
Right. So I'm just going to fill in the answer in my K slots. See how that works? All right, let's try the next one. N times N. Okay. If I use N as a 2, what's my K going to equal?
4.
4. Excellent. You see how you fill out the chart? Pretty easy. Okay. So tell me what 3 would be, Isaac.
6.
Almost. You're adding. 3 times 3 equals what?
That would be 9.
9. Very good. And then 4 times 4?
16.
Very good. Okay? And then this last one will be 16. So that's how you perform one of those problems. Okay, they'll actually give you a set, the position numbers, and then what's the answer the term's going to be is that one. All right, let's try one more for you to try on your own. All right, and here's the problem. K equals 2N. Now, remember, whenever you see a number next to a letter, that means to multiply. So another way you could see that is 2 times N. And I'm going to go in and write it out like that because it's easier for my brain. Okay, so let's go and set up our N's and our K's. Okay, do your same chart, and you don't have to put position and term this time. Okay? Now I'm going to put a 1, 2, 3, and 4 again. Okay, same time. All right, What's going to happen, Isaac, if I make my first n a 1? What is k going to equal?
First and a 1.
I made my n
2.
right here, and a 1. And
That'd
so
be
the
2.
first answer is going to be a 2, right? K equals 2 times 1 is 2. Very good. But what if I changed my n to a 2?
4.
4. Okay? Do the next one, Isaac. Times, what's my n?
3.
3. And what's my k going to answer equal?
It's going to equal a 6.
Very good. And then k,
4.
or if I put my n was right here and I put a 4 there, k is going to equal 2 times 4?
8.
8. Okay? See how that works? And that is lesson 2.